5. Yeah, and we'll be jumping all around. Number 5, yes. Number 5. Now, the important idea for number 5 is you first have to be able to read the inequality correctly. So here, B is greater than C. All right? And there are 2 ways you can approach this. One, you can try to solve this algebraically. That's one way to do it. Algebraically. Or 2, you can substitute values in for B and C. Okay? Just make sure when you do that, that B is greater than C. All right. I tend to go for the algebraic side just because I'm a math teacher. That's what I do. I'll try to show you a little bit of both, but I think most of you can substitute different values in for B and C. As I look at A, B plus C is greater than 2C given that B is greater than C. So I see something that both sides have in common, and that would be the C. So here I would eliminate that C that is the same to both, which cancels that out and gives me B on the left-hand side is greater than, and now you need to remember, because I had one girl that was having difficulty, 2C minus C, it's like 2 cats minus 1 cat, you still have 1 cat. She was saying 2C minus C totally removed the C's. Okay, so her algebra skills were a little whatever. So B is greater than C is what you have left over, and that is what you are given. So I would say that is definitely true. So to justify it, I would say something to the effect of subtracting the same amount from both sides gives B, which is greater than C, which was given. Something to that effect. Okay? Now, that isn't to say what you had, I heard you erasing, that isn't to say what you had was incorrect, but this is probably what I would say. And there's lots of different ways to say that. Okay? Did you want to see all of them, Nehemiah? Kind of go over them? Okay. So, any questions on A? Does that make sense? Letter B, 472 minus B is less than 472 minus C. So what I see the same here is 472. That is the same amount. We know B is larger than C, which is smaller. So if you take away a larger amount from the same amount that both have, this side is going to be, on the left, smaller, right? Or another thing that I could do, algebraically, I could take away 472. You're left with negative B is less than negative C, but I don't want to compare the opposites. So I could divide by a negative 1, divide by a negative 1. What happens when you divide by a negative 1 with an inequality? You flip the sign. So this then tells me that B is greater than C. And that's what we were given, so that is true. What I was saying before, if you start with the same amount and you subtract a larger amount from the other side, then in this case, B would be less than C. But when you solve it this way and you have to flip the sign, B is greater than C. So the way you do it kind of makes a difference. Okay. So you can say what you actually did. Subtracting 472 from both sides gives negative b is less than negative c. Divide by negative 1, and you get b is greater than c, which is given. But that is kind of odd. You do it one way, and you get b is greater than c, and if you do it the other way, it stays as b is less than c. Does that make sense? It's kind of tricky when you say it that way. All right, you tell me, what can I do to see here to figure out if this is true or false? What do you see that's the same on both sides? The c. So what should I do with that c value? Well, I see B, C. What's happening between B and C? They're being multiplied. And between C squared, that's C times C also. So I don't think we want to subtract here. We need to divide. So if you divide by C and divide by C here, you get B is less than, what is C squared divided by C to the first?
Why is it to the first?
If you don't have anything there, it's always to the first power. Like if I have y equals x, that's y to the first and x to the first. It's linear.
Why write it?
Just because people might remember from their exponent rules that when you divide by powers of the same base, you subtract. And so 2 minus 1 leaves you with c to the first, or c. And so, is b less than c? No, we were given that b is greater than c. So this is false for that one. Okay? False. And you could say just exactly what you did. You know, divide both sides by c. Divide both sides by c. You're left with, or gives, b is less than c, which is false. Not what we were given. Does that make sense? Okay. Questions on that? All right. Am I losing people? You guys are very quiet. This is probably one of the toughest things to explain. Once you kind of do it yourself, it's like, oh yeah, that seems to make sense. Or at least I think it does. But yes, to go through it, it's a little tedious. And the last one, 1 over b is greater than 1 over c. This one, I would probably substitute some numbers in. So if b is supposed to be larger, okay, so I'm going to let b, let's make that equal to 5, and let's have c be equal to 2. So if I put 1 over 5 is 1/5 greater than 1/2. Hopefully you know that's no. You can find, if you need to, a common denominator of 10, multiply by 2 over 2 and get 2/10, multiply by 5 over 5 and get 5/10. So here 5/10 is definitely larger, so this would be false. Okay, you can say substituting values of 5 for B and 2 for C gives 2/10, which is greater than 5/10, which is false. Now, is that exactly what everybody needs to put? No. It could be something similar. You also could have trying to think. I have 1/2, 1/5, multiplied by 10. I'm just checking something out here. Oh, but B has to be bigger. So I should have put this over here. This over here. 10, that would have been 2. Yeah, we could have multiplied by B times C. This is another way to do it, because that would have been the common denominator. And B times C over B, the B's would cancel out. And you get C is greater than B, which is also false. So there's different ways of doing it, okay? Again, that's the beauty of mathematics, and that's also the angst of mathematics. There's not just one way to do it. All right, does that help you a little bit? Plus, remember, I have other notes. Hopefully they're kind of similar to this on the answer key, which is on Canvas. All right, other questions? Yes. Number 3. All right, match the expression in each column that are equivalent. Expressions may have one, more than one, or no matches. Here's what I would say for all of these expressions. You want to simplify them as much as you can. So for the first one, we need to distribute and get 2 times x plus 8. And that's the first thing I'm going to do with all of these. For number 3, that would be 3 times x plus 3 times 1 plus 2x. And then you have like terms of 3x plus 2x, which you can simplify to 5x plus 3. This one, number 4 of problem number 3. I would recommend that you rewrite this out as x plus 2 times x plus 2. Because to simplify this, you want to make sure that you do all the distributive property correctly. So x times x is x squared. X times 2, putting the coefficient first, is 2x. And then on the underneath, 2 times x is another 2x, and 2 times 2 is 4. Here are my like terms. And so my final answer is x squared plus 4x plus 4. So right now, I'm not even matching. I am just simplifying all of these expressions. Number 5, 3x plus 9 divided by 3. I would rewrite that or think of it as 3x divided by 3 plus 9 divided by 3. 3 divided by 3 simplifies out. You have x plus 9 divided by 3 is 3. And 3x, that whole thing squared, means you should be squaring both of these on the inside. So that's the same as 3 squared x squared, which is 9x squared. And on the other side, we still have some simplifying to do. 6 gets distributed only with what is inside the parentheses, right? So that's going to be 6 times x plus 6 times 1 is 6 minus x. Here's your two like terms. 6x minus 1x is going to be 5x plus 6. Here we can even simplify. You've got 9 minus 1, so that's going to be 2x plus 8. Am I going too fast? Okay. Over here, 5 times x, 5 times 2, that gives me negative 7 plus 5x plus 10. And you're going to simplify those constants, which gives you 5x plus 3. And I think that leaves them all simplified. So now I can match them up. And I'll do a little bit thicker thing here. So 2x plus 8. So 1 goes with D. Okay. Number 2, 6 plus 5x is the same as B, 5x plus 6. Number 3, 5x plus 3. Wait. Yeah, 5x plus 3. Okay, so that is, bless you, 3 goes with E. 4x squared plus 4x plus 4, that is the same as A, just in a different order. So that's okay. 5, I need more colors. What do I need? Yellow. 5 here matches up with F. And that leaves 6 and C. I'll do that one in orange. Ooh, orange kind of looks like red. Okay. Now, is that the way you have to do it in simplifying them all? No. You know, you can simplify one and then find its match. I was working with someone, I don't know if it was this class or another class, but I was looking at it kind of upside down and didn't realize, I think it was especially this one. You know, I was like 9 plus 2x minus 1. And looking at it upside down, I neglected to see, yeah, that can be simplified. So somebody, I said, oh, well, it says they might have no matches. Well, these happen to match with all of them. Okay? Question, any other questions on that? Okay. Anybody else? Another question. Che. Number 4. Yes. Slay. These are my favorite now. Did she just say slay? Yes, she did. All right. So here's my question to you. When you look at these patterns, this particular one, there are 2 ways that you can do this. How many of you, now when I say this, think about what do you see? What shape do you see? Don't say it out loud yet. Do you see a square minus some tiles? Or do you see a rectangle plus 2 tiles? Okay, how many see a square minus some tiles? Anybody see that? And it all depends on what you see. How many of you see a rectangle plus 2 tiles? How many of you are like, I see nothing? Okay. I think I had more rectangle people, so I'll start with that one. Okay? Actually, Che, you asked this. What do you see?
Well, I thought I saw the arch.
You what?
I thought I saw an arch.
An arch. Okay. And do you know the formula for the area of an arch, though? Just say no. No, I didn't think so. I don't know the formula for area of an arch. But yes. So what I'm asking you is, did you see it, or do you see it now more as a total square minus some parts, or do you see it as a rectangle plus 2 tiles?
It's like a rectangle.
Okay. So if you see it as a rectangle plus 2 tiles, you probably see something like this. And I'm going to go one slightly bigger. Okay. And if you don't see it that way, that's okay. I'll show you how to do it the other way in a minute. So a rectangle plus 2 tiles. So figure one. Let's talk about the rectangle. What is the size of this rectangle? It is 2 by 3. So to figure out the total of number of tiles here, it would be a rectangle of size 2 by 3 plus 2, which gives me a total of 8. Figure 2. What is the size of the rectangle in figure 2? 3 by 4 plus 2 gives you a total of 14. And we can count them and we can justify that. Figure 3, and what is that size rectangle? 4 by 5. So that's 4 by 5 plus 2, which is 22. Now, do you see, without having to count them, do you see a pattern emerging with the figure number and the size of the rectangles?
The figures keep increasing by 1.
Okay, so for the 21st figure, so figure 22, what would be the size of the rectangle? Hang on. Che, do you know? So figure 22, you said the size increase. So figure 22 would have a width of how much?
24 by 25.
Close. So 22, you had figure 1, which was a 2 by 3. Figure 2, 3 by 4. 2, 3, 4. Figure 3, 4 by 5. 3, 4, 5. So figure 22, the next one would be?
23 by 20.
Yes. So you were a little off the first time. It goes in order. The 22nd figure would have a width of 23 and a length of 24 plus 2. Who said that? Very good. And if I had a handy dandy calculator here, who's got that answer? Does anybody know? 554. So if I want to write an algebraic expression for, say, figure n, okay, figure n, what would the length of the side be of this rectangle for figure n? What did you do to 22 to get to 23? You added 1. So if I add 1 to n, you are going to get n plus 1. Now, what is the length of the side up on top? The length on the top? N plus 2, right? Because this was 1 more, this would be 2 more, and then plus 2. And you could multiply that out and get n times n plus 2n plus 1n plus 2 plus the 2, because this is all from within, and you get n squared plus 3n plus 4. Now, if you gave me this, I would take that. If you give me this in its simplified version, I would take that also. That's if you see it as a rectangle plus 2. Where are my people that saw a square minus? I know Andrew raised his hand. And Yasmin, right? Yasmin. Oh. All right, so I'm going to do a little bit of erasing here to show the other version, which again, math is great because there's more ways to do it, and math can be irritating because there's more ways to do it. So if I see this as a square minus pieces, we're looking at this as a whole square minus pieces, okay? So this would be, what's the length of this side if I see it as a square? Oh, that's too big. Yes, a 3 by 3. I'm going to do this underneath. A 3 by 3 and then minus 1. For figure 2, that square is a 4 by 4 minus 2. And this would be a 5 by 5 minus 3. And if you do that, you are going to get the same answers. 5 by 5, 25, that's 22. So if I'm looking at the 22nd figure, and from figure 1, it jumped to a 3 by 3. Figure 2 jumped to a 4 by 4. Figure 3 jumped to a 5 by 5. So how does the figure number compare to the length of the side of the square? You're subtracting the figure number, but how do I get to the square amount? I have to add 2, right? So the 22nd figure would be 24 by 24 minus the figure number itself, which is 22, which hopefully is 554. I'm pretty sure it is. So then for this figure n, it would be n plus 2 times n plus 2 minus n. Running out of space. So if you work this out, n times n is n squared plus 2n plus 2n plus 4 minus that n gives you n squared. Putting these 3 together, and I am recording this too, 2n and 2n is 4n minus n gives you 3n plus 4. Which is the same as you got over here. I would take that, or I would also take that. So again, different ways to look at the same problem. It all depends on what you see. Okay? Other questions? We have about 6-7 minutes. It wasn't that funny. Oh, is this over the top? Was that over the top?
No.
Oh, okay. Factors. Everybody know how to factor? How about number 9? That one had more than one answer. Or you tell me, are there any other questions? So look at number 10. What do you see in number 10? Do you guys have number 10? Oh, okay. Well, I think, was that on the answer key? I think it was. So if you want another type of these problems, what do you see in this problem? This is good just to do with you guys now then, if we don't have this. Maybe put it on the back. Just looking at it. How many squares will be in the 59th figure? What do you see in this visual pattern? What do you see? What? 4 gets added. Say more. What do you mean by that? So what do you think the 5th one would be? You said added 4. I see 4 here. And maybe I'm looking at it differently. Tell me what you see. What shape do you see? A square and a tail, right? Essentially. So here's my square. What is the size of this square? It's a 4 by 4. And how long is the tail? 4. This, for figure 3, what's the size of that square? A 3 by 3 plus 3. A 2 by 2 plus 2. A 1 by 1 plus 1. So the 59th figure would be and show us what size square? A 59 by 59 plus a tail that is 59 lengths long. What would that look like algebra? And you could figure out that answer. What would that look like algebraically? That would be n times n, because we're at figure n. N times n plus n, or n squared plus n. Okay? Other questions? Okay, so you guys are packing up a little early. No other questions? So I will take this and collect it tomorrow. If you want to turn it in, basically it has to be mostly done for like 10 points. Why is it only 10 points? Because I have given you the answer key and the work too. Even if you did it yourself, I have given that to you on Canvas to check in and make sure it's right. Okay? So if you want to turn it in, I will collect it. It will only be collected tomorrow. Or I should say on the same day you take the test. So for some reason, if you get mysteriously sick tomorrow, I will collect it on the day of the test. Hopefully most of you will be here tomorrow. Any other quick questions? You know how to factor. Make sure you factor out a negative if your first term has a negative. Right here. Hey, let's look at 8b while we have some extra time. What is my factor going to be for 9x plus 21? Yes, right. I saw a lot of people at first kind of doing this, and if it's a factor, it has to go in there evenly. So we can't have any halves or 0.5s. So yes, 9 is not going to be the greatest common factor. It's going to be 3 times 3x plus 7. Okay? So this is a factor, and this is a factor, or this is the product. And this, if you multiply it back, you should get the same answer at the front, which is 9x plus 21. So that's kind of just doing a check. This is the sum of your areas. Okay? This one. I'm surprised you guys didn't ask about this one. This one's a little complicated. So n plus 6, n plus 6. is going to give you n squared. This is going to be 6n. This is going to be 6n. And this is 6 times 6, which is 36. Okay? But I will be here tonight after school if anyone comes. Have a great rest of your day. Tomorrow is test day. You want to do well on this first one. If you don't want to take it yet tomorrow. You what?